Now, when graphing a polynomial, some of what I consider to be the most important points to get absolutely correct on the graph are the intercepts, the x-intercepts and the y-intercepts. So let's start off with this definition. The values of x that make a function equal to 0 are called, and there are about 3 terms here, it can be called roots, zeros, or x-intercepts. They all basically mean the same thing. And another term we would use is if you have the equation written out, f of x equals 0, we're just finding the solutions to this equation to get the roots, zeros, and x-intercepts. All right, well, let's find the roots. I used roots here and I used zeros here. I could have said, in either case or both cases, I could have said find the x-intercepts of these functions. Now, how do we find the roots of this function? Well, we know what we have to do. We have to set this equal to 0. Set this equal to 0. But how do we solve that? Well, we need to factor. We will be doing a lot of factoring from now on to throughout the rest of the course. So we haven't ever factored in this class. This is called a cubic, a degree 3 polynomial. Now, this one isn't too hard to factor if we do it by a method called grouping. You may have heard of grouping. You may have done that before in a previous class. I'm going to group those 2 terms together, and I'm going to group those 2 terms together. Now let's factor these 2. Well, the only thing you can do is pull out the greatest common factor, which would be, between these 2, would be x squared. So let's pull out the x squared. And what does that leave us with? That would leave us with an x plus 2. You can verify that by doing the distributive property here. X squared times x gives us x cubed. X squared times 2 gives us positive 2x squared. Now what are we going to pull out of this? Well, looks like 2 can be pulled out, or we could do a negative 2, because notice what I want to have happen when I do the factoring is I want to have x plus 2 in the parentheses in the next term. So I'm going to pull out a negative 2 minus 2 times, sorry, I said 2. I should have been saying 4 that whole time. The greatest common factor of these 2 terms would be a 4. But we could pull out either a positive 4 or a negative 4, so we're going to pull out a negative 4. So when we pull out a negative 4, it's going to give me an x plus 2. You can verify that by distributing negative 4x, and negative 4 times 2 gives you negative 4x minus 8. And it only works, grouping works, when you have, after you do this, that you have a factor that's here that's exactly the same as here, and it did work out. So I'm going to pull out the common factor of x plus 2, and what has that left me with? X squared minus 4. Not done factoring. We're going to factor this now. This is a difference of 2 perfect squares. So it'd be x plus 2, x minus 2. All right, and then once we get it fully factored, how do we find the roots? We really use the zero factor property. We set each one of these factors equal to 0 and solve. So this one, which is the same as this one, tells us that if we subtract 2, we get x equals minus 2. So the roots are negative 2, positive 2. Now we usually don't bother duplicating or writing down twice the duplicated roots, so probably we would just say plus and minus 2. Those are the 2 roots. And we'll learn in a minute, we have a term for this root of negative 2 that showed up twice. We'll see down here that we would say the negative 2, count these. We've got 1, and 2. So negative 2 is a root of multiplicity 2. It showed up twice. The root of positive 2 is multiplicity 1. So negative 2 has multiplicity 2, 1, 2. And positive 2 has a multiplicity of 1 because it only showed up once. Okay, let's do the next one. Find the zeros of x to the 4th minus 4x squared. So just to make sure I have enough room, I think I'm going to move over here to the left. X to the 4th minus 4x squared. And what do we have to do? We have to set that equal to 0 and factor that left-hand side. So we'll pull out the greatest common factor, which is between these two terms would be x squared times x squared minus 4. And again, you can do the distributive law to verify that we did this correctly. And then x squared minus 4, well, that's the difference of two perfect squares, actually, just like we had up here. So it turns out that we would get x squared times x plus 2x minus 2 equals 0. And so we have these factors. Set that equal to 0, set that equal to 0. And we would get, as the zeros, again, the zeros are the same as roots. I call them zeros here and roots in the previous example. X squared equals 0 means x equals 0. X plus 2 equals 0 means x is a negative 2. X minus 2 equals 0 means x is a positive 2. So in this, we got 3 zeros. 0, negative 2, and 2. And since I'm getting right into the multiplicities, let's take a look at these again. The multiplicity of 2 is 1. It only showed up once as a factor. The negative 2 came from this, and this factor only showed up one time. But 0 came from this factor. And if you wanted, you could write x minus 0 squared in place of x squared. And that means it showed up twice, the exponent here. So the multiplicity of 0 would be 2. The multiplicity of each of these would just be 1. All right, so actually, we've already talked about it, but let's formally define multiplicity. In a factored polynomial, if x minus r shows up, like x minus 2 here, or x plus 2 even, if x minus r occurs exactly k times as a factor, then r is a 0 or a root with multiplicity k, because it showed up k times. So that's really, if you completely factor it, let's go back to this earlier one just for a second. The way I really would have written this in factored form, since x plus 2 showed up twice, I really would have preferred to write it like x plus 2 squared times x minus 2. Set that equal to 0. That's just the same as what we have here. All you have to do for the multiplicity is just take the exponent. Negative 2 is a 0 in this one because of this factor. And negative 2 is a 0 of multiplicity 2 because of that 2 exponent. 2 is a 0 because of this factor. And I'll go ahead and write the 1 up there. It is a factor, it is a 0 of multiplicity 1 because of this exponent. So let's do this example in number 7 to find the zeros and multiplicities of this guy. All right, so let me write it way over here to the left. X to the 5th minus 4x to the 4th plus 4x to the 3rd. We have to set it equal to 0 because we have to find the zeros. So the first thing you do in factoring is you pull out the greatest common factor. And in this case, the greatest common factor would be x to the 3rd power. And that would give us x squared minus 4x plus 4 in parentheses. And you can verify this. X cubed times x squared is this. X cubed times negative 4x is this. X cubed times 4 is this. And then we get to factor one more time what's in parentheses. So we get x cubed. And how do we factor this? X squared minus 4x plus 4. It's a perfect square polynomial, trinomial. It's going to be x minus 2 quantity squared. Hopefully you're good at factoring this kind of thing, but you can double check by taking x minus 2 times x minus 2 and verifying that you get this trinomial right here. All right, we're just about done then. That means that the zeros are what? 0 and 2. And their multiplicity of 0 as a root would be 3. And 2 would have a multiplicity of 2. And you'll notice this, I may emphasize it again later. What happens if you add up all the multiplicities? The multiplicities give you 5. Well, notice that this is a 5th degree polynomial. You should always get that. Because remember, if you don't remember, when you have a polynomial of degree 5, you're always going to get 5 zeros. Now, I want to qualify that because they could be repeated. This one we only have 2 different zeros, but 0 has multiplicity 3. You could say this is x times x times x times x minus 2 times x minus 2. 5 factors, 5 multiplicities. Okay, now let's talk about what that multiplicity does. Does it help us when we're graphing? Well, it does. If r is a 0 or a root of even multiplicity, like this one right here, 2 has multiplicity 2, then the graph touches, and I'm going to put in parentheses, without crossing the x-axis at x equals r. So if r is a 0, remember what that means. At x equals r, that's an x-intercept. It crosses the x-axis at this value. If it's even multiplicity, it's not actually going to cross through it. It touches it, and then, it could go down and then up, or it could go up and then down from underneath. It will touch it without crossing. Odd multiplicity, then the graph crosses. Crosses right through the x-axis at x equals r. So for homework, if it ever says, find the x-intercepts, or the zeros, or the roots, and state whether it touches without crossing or whether it crosses, you can just use the letter T for touches without crossing and C for crosses. And this is a fact that if the multiplicity of 0 is greater than 1, like 2 or 3 or 4 or 5, the graph tends to flatten out at that 0 or at that x-intercept. For example, I'll draw a little graph here. It could do something like that. It tends to flatten out. It comes down here and slowly goes back up. Or even if it crosses through, it's going to go like this. See how it flattens out there a little bit? It's not going to do this. Go straight through it. Okay. We're not going to graph this, but let's discuss the zeros or roots or x-intercepts of this graph. Since it's factored, that's very easy for us to do. Zeros are what? Well, -2 doesn't have an x here, so -2 is never equal to 0, so that's not turning into a 0. X minus 2/3, set that equal to 0, and we would get 2/3 as 1, 0. And x plus 4 means x minus 4 is a 0, or an x-intercept. Now let's write the multiplicity of each of those. So the 2/3 would have a multiplicity of 2. -4 would have a multiplicity of 3. So it would, at x equals 2/3, it would not cross through the x-axis. Of course, it touches it, but it would touch it without crossing, because 2 is even. But 3 is odd. 3 is odd, so at -4, it's going to cross right through. Now, it would tend to flatten out there, but that's fine. So, I have a question for you. I'll be impressed if you could tell me what, if you multiplied all of this out, what would the leading coefficient be? If you multiplied all of it out. Let's ignore the -2 for now. If you multiplied x minus 2/3 times another x minus 2/3, the first term would be an x squared, right? Let's look at this by itself. X plus 4 times another x plus 4 would give you an x squared, times another x plus 4 would give you an x cubed. So the first term of this, if you multiplied it out, would be x cubed. The first term of this, if you multiplied it out, would be x squared. What would you get then when you multiply the x squared by the x cubed? You'd get an x to the 5th power. So the leading coefficient is going to be x to the 5th times this guy. This is going to be multiplied through by everything. So the leading coefficient would be a -2 x to the 5th power. And that makes sense, 5th power, because notice the multiplicities were 2 and 3, which add up to 5. And that really means you have 5 zeros or 5 roots, but there are only 2 distinct zeros, 2/3 and -4. This one is a 0 or root of multiplicity 2, shows up twice, and this one shows up 3 times. And this, we have a negative number for the leading coefficient. We have an odd degree for the polynomial. So what does that mean? Is it going to, for the end behavior, left and right? Let's see, x to the 5th would be falling left, rising right, but we have a negative coefficient, so it's going to be rise left, fall right.